So phase 2, tank creation. So what we're going to do in this one is we're going to put in our tank model, and then that tank needs a number of different components in order to function. So the tank model looks like this, and it's going to need a rigid body for physics. It's going to need a collider. So you can see this kind of green outlined cube here. That's for interactions with things, so it can bump into objects. It's going to need one audio source to play back the sound of it driving around. It's going to need a second audio source to play back different sound effects, so like shooting and things like that. And then this tank movement script that we're going to write a bit of. And then when we're done, it's going to drive around like that and play the audio. It's also going to have these particle effects that we're going to drag and drop on there. Cool. Okay, so let's dive back to the editor and we'll recap in a moment. Okay, so the first thing we're going to do is jump into the models folder. So in the project panel, we've got all of these different assets that were made for the game. Most of them there are just parts of the level art thing. And we are going to grab hold of the tank and drag and drop that into the hierarchy specifically. So what you'll notice is that when you drag things into the hierarchy, it's going to position them at 0 unless they were a prefab with a predetermined position. So this tank isn't a prefab, it's just a model. So what you'll find is that it's placed it right in the center of the view, just like we planned. So what I want you guys to do is, first off, let's just learn a quick shortcut. So if you select anything in the hierarchy, the tank being the example that we want, and hover over the scene view and press F for frame selected, you can zoom right into the thing that you're looking at. So once you've framed your tank, we can start working on it. So the tank will be one of 2, or if you wanted to extend the game, several tanks. Because we want to be able to tell the difference between the tanks in the game and other objects in the game, we need to put the tank onto a particular layer. So what we're going to do is select our tank, and at the top of the inspector, you'll see a drop down for layers. Currently it will be set to default, but we want you to set that to players. And why do we do that, James?
So when the shells explode, they're going to do an overlap sphere, which you don't need to know about just yet, but you will do later. That's going to find all the colliders, but we're going to tell it to find all the colliders on a certain layer, so that we don't blow up the buildings or the ground or anything else. We just want to blow up the tanks. So it's just going to find the tanks because they're on the player's layer.
Yeah, so basically whenever a shell lands, we're going to create a kind of blast radius for this thing. So we need to only apply that to other tanks. So every tank will be on this particular layer, and we'll restrict that. Then what you'll see is that it will say, change layer. Do you want to set the layer for the child objects as well? And we'll say, no, this object only, because we only need to apply it to the part that has the collider, which will be the parent object of the tank. Okay, so quick recap. We've brought our tank model and dropped it into the hierarchy panel. At the top of the inspector, we've set the layer to players. For the change layer, we chose it to be no, this object only, because that's going to be the one with the collider on it. Nice and simple. So then we're going to dive in and create those components that we just saw. So there's a few ways to add components in Unity. We're mostly going to use the Add Component button here, but you'll also notice that there's a component button at the top of the screen with all of the same components in it. If you click on the Add Component button, you'll see that there are ways to search for components, and that's usually the quickest way to do it. If you know the name of the component that you want, then you can start typing and it will auto-complete for you. So for example, I would type rig to get straight to rigid body. Another important note, when you're adding these components that we're going to reference throughout the day, there may be 2D equivalents of all of them. We're making a 3D game this time around, so try and avoid adding a 2D equivalent because it won't do what you expect it to do. So the first one we're going to add is rigid body. So I'm navigating using up and down arrows on the keyboard. I can also press return to choose one that I want. Add rigid body that way. So the rigid body component basically invokes the physics engine. So there's a bunch of different parts of Unity that are kind of bolted together behind the scenes. And the physics engine's, just another example of one of those. But basically what we do by adding rigid body is say that this particular object is governed by that system. And anywhere we want to move it should be done using, an API or scripting that controls the rigid body system. So our rigid body, first of all, will need some additional settings. So because our tank is just driving around on the ground plane and rotating around the y-axis, we don't want it to jump up and down. So we're going to freeze the position of the y-axis by checking the Y box by constraints. So make sure you have constraints expanded. So I'm going to refer to expanding and collapsing things in Unity at various points. The arrow to the left of things is how you do that. So when I say expand, I mean to open these up to see further settings. So I'm going to check the box for Y, and then I'm going to freeze rotation for X and Z axis, as you guys would say. So we don't want the tank to kind of roll. We don't want the tank to kind of spin backwards. We only want it to rotate around Y in order to steer it. So we can just lock those off. So if you're ever making games where things are constrained to a certain axis, you can just use the rigid body to force it into place. Quick recap. We've added the rigid body. We need to constrain positions and rotations. So we've checked freeze position for Y and X and Z or Z. So how does physics work? Well, the physics needs some kind of collision to actually make it work. So the rigid body there is there to say, hey, this object is governed by the physics system, but it's not going to receive any events or any information until we have something called a collider on there. So it's another component that we need to add. So I'm going to click that add component button again, and I'm going to type in box this time. A box collider is what we need here. So just a quick note. What you'll see when you look at the level art, so I'm just going to show that very quickly, is that we've used what we call primitive colliders for a lot of these things. We haven't used a detailed collider for pretty much anything at all. So this entire level and all of the interactions that you'll make with it is governed by what we call primitive colliders. So-called primitives because they are what we call primitive shapes, spheres, capsules, cubes or boxes in the sense that colliders are called. So you can see that all of these different rocks and things are differently sized capsules and differently sized boxes. And that's exactly what we're going to do with the tank. The tank doesn't need a really detailed shape for its collision or what it's going to do. So all we need to do is put on a box collider, and that's going to be just fine. So I'm going to add my box collider. So search in the add component button, choose box, hit return, and we're going to add that on there. So what you'll see when you first add that, however, is that it's not quite the right size. It's going to be just stuck underneath the tank, and it looks like this. So sometimes what Unity can do is it can look at a mesh component, and it can say, okay, well, I can tell how big the collider needs to be as a result. But because our tank has a parent node before it gets down to its actual rendered mesh parts, which are these child objects, the physics engine doesn't check that. So don't get confused if you add a collider and you're like, oh, Unity, why don't you set it to the right size? Sometimes it's just not going to do that. But there's a number of different ways that we can set up our collider. What we can do is use the Edit Collider button, which is this toggle on and off here. But we're not going to use that. We're just going to give you settings for this thing. So the center value, I'm going to give you a value of 0, 0.85, and 0. And then in the size, 1.5, 1.7, and 1.6. So once you've put those in there, have a look at your tank. It should be roughly the right size to fit and encompass the tank. And we'll just jump back into the slides to remind ourselves. We've added a box collider to our tank game object. And on that box collider, we've changed the center to 0.850. So remember, I'm saying these in X, Y, Z order, or if they're colors, RGB order. And then we've changed the size to 1.5, 1.7, and 1.6. So the next thing we need to do is allow this tank to play back audio whenever it's driving around. So this is going to be a game that's got 2 different tanks in it. There might be several more tanks if you extend the game. But what we want to do is make sure that these tanks aren't all playing exactly the same audio clip at the same pitch. So what we do is we have an audio source that's playing this back, and we vary the pitch. And we're going to do that in code later on. But it does mean that we have a couple of audio sources on this tank. The first one being for our engine sounds. So the quickest way to get to that, and as I pointed out earlier, you can go to these different sections. So I could go to audio and choose audio source here. But I know an audio source has the only source in the entire component list. So I usually just tend to type SOU, and that gets me straight to source. I can hit return. So this particular thing is going to be playing all the time. So the tank's engine is always running, whether it's driving or whether it's idling. So we want to check loop. And then the first instance of choosing assets is what we see next. So at the top of any audio source, you see audio clip. So it's basically the file that's in your project that this is going to play back. So there's a few different ways that you can assign this. The quickest way to do it is just to click on what we call circle select. It's this little target looking thing over on the right here. So if I click on that, it's going to pop up a new window and list all of the assets that are appropriate for that type. So what you'll notice is that whenever there is a field that you can drag something to, so if I show you here, you can see, for example, on the box collider, I could add what's called a physics material. And for the audio clip, I can add an audio clip. And for the output, I can set an audio mixer group. These are asset types that will be in the project that are valid to assign it to. So whenever you see none, nothing's assigned to it yet, but you can put in whatever's in those brackets. So Unity knows to show me a list of audio clips because that's the type that's being expected. So I'm going to choose engine idle, and you can either hit return or you can close the window, but if you double click on the name, it will choose it and close the window at the same time. So one more time, click on the circle select to the right of the field that you want to fill in, and then you can double click on the name of the asset that you want. And of course, the other way to do that is if you want to select the audio clips in the project, as in the folder, you can drag and drop files to assign them like that. So one more time, we've added an audio source. This is going to allow the engine sounds to be played back, and we have set engine idle as the clip to play back, and we've checked loop to make sure that it constantly plays. The second audio source that we need is going to be for sound effects. So the tank, and it's also going to be able to fire shells. So the two sound effects that we're referring to is the sound of charging up the weapon. So these tanks, as you saw in the video, have a variable range. So you can hold down fire. I'm sure some of you have played the game Worms before. When you fire a bazooka, you hold down the button, charges up, and then when you let go, it fires. Or if you hold all the way to the end, it will just fire anyway. These tanks are going to work just the same as that. So we're going to use this second audio source to play those sounds back. So one more time, add component, and it will still be on hopefully the same thing if you typed in a search. If not, you can just type SOU, or you can go to audio source to add a second one. So what's quite useful when we're adding a lot of components to an object is just to collapse them to make space. So what I'm going to do is just collapse my rigid body, box collider, and my first audio source. So I'm definitely working on the second one. Now, we're going to use a script to tell this audio source which particular audio clips to play. So we're not going to assign that there. We do want to uncheck play on awake because we don't want this particular audio source to play anything at all. And that's kind of the basics of our tank setup right now. So I'm going to quickly just save my scene. So file save or Command S, Control S shortcut. And then because our tank, when we've finished making our game managers towards the end of the day, we want to spawn our tanks when the game starts. We're not going to leave the tanks in the game because we want the tank to be created by a game manager object. And that manager is going to be in charge of creating the tank, giving it a color, assigning it as player 1 or player 2, telling it which keys on the keyboard to use and things like that. So our tank needs to be stored as an asset in the project. That's really important. We can't just leave it as a game object in the scene. So as you saw when we started the day, we dragged in the prefab of the level art, and the level art has the light, it has all of the colliders to denote where all of the interactable things are. We're going to do the same thing with the tank. We'll save it as a prefab. So if you select the prefabs folder on the project, and then all you need to do is just grab the tank, drag and drop it into that prefabs folder. You can either drag here to the empty space, or you can drag onto the name of the folder itself like that and let go. When you've done that, you'll see that it's another item in the list with the same icon. This blue cube means it's a prefab. And the other thing that will tell you that you've done it correctly is that the tank is now highlighted in blue. Actually, it may be blue before that because it's a model and they also get highlighted in blue. But basically, the other way to tell is that by selecting the tank in the hierarchy, you now get these prefab options at the top. You should see prefab, select, revert, apply. So basically, whenever you make changes to the version in the active scene that you've got open, you can update the asset that you just made. So just a quick recap. We have added another audio source for our sound effects. We've made sure to uncheck play and awake. And then we've selected our prefabs folder. We've put the tank into that prefabs folder. So now we can make as many copies of that tank as we want to. And what you'll notice is if you click on the tank in the prefabs folder, it's got everything that we just set up. So prefabs are that way of kind of creating all of your settings, setting them up the way you want, and then you can just spawn as many as you need to. And hopefully everybody has saved their scene. If not, please do that now. Okay, so our tanks are driving around. It's a dusty, sandy desert, so we're going to need to see some dust trails coming off of these. So we've created those for you. If you look in the prefabs folder, you'll find something called dust trail. So these dust trails are particle systems, and particle systems in Unity allow you to basically spawn a number of flat sprite objects that are creating the effect of dust or sparks or any of these kind of things that aren't made up of 3D meshes. So they're just for effects. So the particle system that we've got here has a number of modules. So I'm just going to explain very briefly how this particular one works. We're not going to dwell on it too much. But what I'm going to do is just drag my dust trail and drop it onto the tank. So I want you to do that as well. So grab dust trail prefab and drop it onto the name tank in the hierarchy. So one more time, I'm just going to zoom in so you can see a bit better. I grab dust trail, I drag it up, drop it onto the tank, and then it will appear as a child object here. So this dust trail, if I just drag it around, I'm just going to show you briefly. You'll see as I move it around, it starts to create particles. The reason for that and the way that you can achieve that effect is by having the simulation space set to world and then having the emission based on distance. So usually particle systems emit over time and you choose the amount of particles you want to emit at any time. You might create bursts of particles every so often, but this is using distance. And what that means is whenever I'm dragging a bunch per unit, I'm getting 10 at a time. So one unit moved is going to create a whole bunch of them and they keep kind of moving around. Then what you'll notice is that as I drag them, they are appearing and getting smaller. And that's because our size over lifetime is using a curve. So this curve basically creates it at a certain size, and then lifetime is basically from the moment that they appear to the moment they disappear, what's going to happen. So the lifetime of those particles means that they're getting smaller using this curve. So that's our basic particle system, nothing too complex, but we do need two of them, one for each track. So what we're going to do is to select it and then duplicate it. So select your first dust trail and then you can either right click and choose duplicate, or you can do Control D or Command D if you're on a Mac. And then we're going to rename those two. So we want left dust trail and right dust trail. And you'll notice that it's added a 1 on the end because they had the same name. No big deal. So I'm pressing return on the Mac to rename. You can press F2 on PC just like your operating system to rename things in the hierarchy. Quick recap. From the prefabs folder, we've dragged our dust trails on and we've made them child objects. So when you see something sort of indented under something else in the hierarchy, we call that a child object. It's attached to it, it will move with it, so these dust trails will get dragged around by the tank, and the distance will cause them to emit particles. And we've renamed them left and right dust trails. So we're jumping ahead here with the slides, but those are the positions that you need. So I'll show you that in just a moment, but for those of you who are ready, the position of the left dust trail should be minus 0.5, 0, minus 0.75, and the position of the right one is 0.5, 0, minus 0.75. It's probably easier for me to leave those up, but for those of you who are unfamiliar, forgive me. For those of you who are, I'm just going to quickly show you what I mean. So the left dust trail, I'm going to set the position in the transform component to minus 0.5, 0, minus 0.75. So we just set the position here in the transform panel. I'm going to jump back to the slides for those positions. Right dust trail is 0.5, 0, minus 0.75. Should look like this and this. So just slightly offset. Okay, so then we're going to get on to actually controlling our tank. So I'm just going to quickly save my scene. Then I'm going to look in the scripts folder in the project panel. So we've split up our scripts into a bunch of different areas. We've got the camera, manager, shell, tank, and UI. And you guessed it, we're going to look in the tank folder for this script. Tank movement is the script that you need. Now, scripts are components. They're ways of creating behavior for your game objects and ways of governing how the entire game will play. This particular example is going to be in charge of allowing us to control the tank. And because scripts are just components, the same as any of the other components in Unity, we need to attach them to a game object to make them do stuff. So there's a bunch of different ways that we can do this. The way that we're going to use today, that's pretty straightforward, hopefully, is just the drag and drop method. So I'm going to collapse my tank. I don't need to see the dust trails right now, and it's going to make sure that I drag it onto the right object. And I'm going to grab tank movement and drop it onto tank and let go. So you should see that your tank movement script appears as one of the list of components there.
Something quick to note is that some of you may have noticed there is a complete folder in your project. Ignore it, don't touch it. That's just the finished version for you to look back on later. The downside is that we've got two versions of the scripts. There's one version that's complete and one version that we're going to work on today. So if you use the add component button to add a script and then try and find it, you're going to see two versions of all the scripts.
Yeah. Thanks, James. Yeah, so when you search under add component, you'll see that there's two of everything. That's why we're getting you to do the drag and drop method. It just avoids that confusion. Yeah. But the advantage of having this completed version of the project is that you can just go and look through it afterwards. Also, all the scripts in that are complete and commented. So we've written comments explaining what every part of that does. So when you get to the end of the day and you're like, oh, it's overload, I can't remember everything those dumb British guys said, I didn't really understand their accents anyway, then you can just go through and read all those comments. So we've dragged on our tank movement script and we're going to keep dragging and dropping scripts. So bear that in mind. In the script, the things that we're going to do are to get the input, we're going to set up the audio, we're going to set up forward and backward movement, and we're going to set up turning. So without further ado, let's get into our first bit of scripting. There's a few different ways you can open up a script. Okay, so the main one that I tend to use, and this is just through habit, you might have a preferred method, is to double click on the name in the script field of the script component. So you can double click here on tank movement, and that's going to open up your script editor. So for people on Mac, that's probably going to be MonoDevelop if you haven't set up something different. For those of you on PC, it may well be Visual Studio, but there's really no difference for the kind of stuff that we're going to be doing. You know, it's not going to matter whether you use either bit of software. As long as the code and the lines and everything looks the same, it's all going to work out fine. Next, the thing that we need to explain for scripting during this training day is that there are scripts that are partially completed and there are some that are totally complete, and we're going to be working with a mix of the two throughout the day. So what you'll notice about this first script is that there's some of it in gray. Now, why is that? Well, that's what's called commenting. So a comment is there to basically disable part of the code. So if you are trying out programming and you've got an idea for something and you want to try it out, but then you're not sure, you go back, you want to disable it, but you don't want to delete it, you can just put in what's called a comment. You can also use comments for actually what they sound like. You can write in, you know, hey, you know, this variable is cool. This variable rocks. It's my favorite variable. And you can just write notes. If you're collaborating with someone, comments are useful, obviously, to leave notes. Or if you have a terrible memory like me, you want to leave notes for yourself, then that's another good thing to do. We've used comments to disable bits of the code so that we can re-enable them and then start working. If we didn't do that, then the scripts would give you a load of warnings when you opened up the project. And we didn't want to scare you guys or confuse you, so we just disabled a bunch of code to start out. But it's very simple to undisable it. We just need to remove the comments. So comments, in this sense, are these two characters, /*. If you get rid of that, that will remove the start of the comment, but you also need to remove the end. So on line 13, delete those two characters. You'll then see the syntax colors for the programming coming back. So you'll see all these different colors, but you also need to scroll down and remove on line 49, the opposite, */. So it uses those to create what we call a block comment. If you want to write a number of different lines, then you can do /*, write a whole bunch of stuff, and then the reverse at the end. So we've done that to disable that whole section of code. So once you've done that, you should be good to start writing. The other thing to mention is single line comments. You'll notice that in these other 5 different functions, we've got single line comments. So you see // will allow you to do a single line comment. Those are literally comments. They're just us telling you information. So we're telling you roughly what we're going to do in each function. So when you do start writing those, you can just move down a line and get started. Comments will not break code. They will just disable it. So the compiler, so the thing that runs the code in the engine, will not run it. It will just ignore it. So you don't have to worry about those at all.
Almost all scripts in Unity are going to have a bunch of variables at the top, and these are member variables. And that is actually the reason that you see this M_ on all of the variables. So that M_, it doesn't change any functionality. It's just us labeling it to say that this belongs to the class, so you can use it in any function. So other variables that we create within functions will only work within the function that they're created. However, if you see an M_, that's going to be usable anywhere.
Yeah, so we create all of these different variables, and we know that if we're referring to something that we set up, often if they're public variables, for example, so you can see we've got 7 different public variables there. And I look back in Unity, you'll see the same fields here. So player number, speed, turn speed, etc., etc. These are all our public variables set up, and they're all our member variables. So we're going to need them and reuse those values throughout the script. If they're not things that we need to assign or drag and drop or tweak during our kind of game design phase, then they're likely to be private variables. So public variable invariably will be appearing on the inspector for that component, and you can change things. Obviously, if you want to change speed, you want to change turn speed and tweak how the game behaves, that's why they're public. And then the private variables there are designed to just create functionality within the game. So let's go from top to bottom and explain what these variables are doing. So just a quick note, this is C#. We'll be teaching with C#, and generally that's what we recommend that people use with Unity. The other option is what we call Unity Script, which is a JavaScript-like syntax for Unity functions. But we prefer to use C#. Okay, so first off, our public variables. So you'll note that we have the first one there called player number. So we have public, that's the accessibility, int for integer, whole number, and then we have player number. So when we're writing this code, we're going to try and remember to keep saying M_player number or M_ whatever it is. But if we say one of these variables and it's one that you remember is an actual variable, then you'll see that hopefully the autocomplete function of the code editor will actually kick in and remind you to do that. So you can autocomplete by typing any part of the variable name, and I'll show you that in a moment. So the player number, what does that do? Well, our tank manager needs to govern how many tanks there are and which controls are assigned to which tanks. So in this particular game we're going to make today, there's going to be 2 tanks, a red one and a blue one. And the player number is there to kind of say, okay, well, if we're player number 1, then we need to inform the UI to say player 1 has won this round. And it also needs to say, okay, well, a bunch of inputs with a 1 on it will be governing tank 1. So we're going to be using W, A, S, and D and spacebar for one of the controls, and then the up, down, left, right arrows and the return key for the other tank. So we have those set up in the input manager, which we'll show you as well. But the player number is there to define and assign those controls, and you'll see how that works briefly. Then we've got some more self-explanatory stuff. So speed is how fast the tank's going to drive. Turn speed, how many degrees it's going to turn over time. Audio source movement audio. So that's our first audio source that we added, which is going to have our engine idling, engine driving. Then we've got clips for both, so that whether you're holding down a key to drive or stopping again, we'll play those two different clips. And then we have pitch range. So I mentioned earlier about how we're going to vary the pitch. And so we put in this small value of 0.2. And what you'll see later on is that we use a function called random.range to keep changing between the current pitch and either plus or minus that small differentiator. Then our private variables.
Okay, so whenever you make a call to an input function in Unity, you usually have to pass in a string for the axis name.
What's a string, James?
So a string is a series of characters, might be a word or a sentence, something like that. So a lot of you who are familiar with Unity, you'll be used to something like horizontal as one axis, vertical as another axis. And then you've got fire buttons, fire one, etc.
So I'm just going to show it real quick. So if you just watch the screen, you don't need to do this yourself, but this is our input manager. It's available from Edit, Project Settings, Input. And you'll notice if you are used to a bit of Unity work before, this is slightly different to what you normally see. We've basically set up UI 1 and 2 controls. So we've got fire 1, and it's got those, for example, spacebar for firing 1, and it's got fire 2, which is return or enter key. Okay, so in order to get the input from one of those specific axes, we need to use a string, which is its name. So to find horizontal 1, the horizontal controls or the turning controls for player 1, we need to say input.getAxis horizontal 1 as a string. So since this script is going to go on multiple different tanks, we need to change which axis name we're using based on the player number. So when we get to the start function, you'll see it being set up. All that's going to do is store the name horizontal plus then the player number so that it gets horizontal 1 if it's player 1, horizontal 2 if it's player 2. And then likewise, we've got the turn axis name. Oh, sorry, that was turn axis is horizontal, move axis is vertical. Yeah.
Then we've got a rigid body component. So that's just going to store a reference to the tank's rigid body. And we're going to use that to actually move the tank around. Then we've got two floats, and these are the input values. So when we've actually got the input, we've used input.getAxis, we'll store that, and then we can use it wherever we want, because it's a member variable. Finally, we've got the original pitch. So rather than varying around the current pitch of the tank, we vary around its original pitch, because if we vary around the current pitch and it keeps on getting higher and higher and higher, you're going to end up with a very strange sounding tank. Okay. So first function there is the awake function, and that is called, regardless of whether the tank is on or off, when the scene very first starts. So all we're doing there is using getComponent rigid body to store that reference to the rigid body.
Yeah, so you'll see this a lot. You'll see getComponent in awake functions in a few of these scripts, and basically it's just storing a reference to a particular component on a particular game object. Now, here we're saying just get component rigid body, but you could make a reference to another game object and get a component reference to that stored if you really wanted to. We're just saying get component, which says, okay, this script is attached to a particular game object. Look at the list of components there and grab the one that we put into these angled brackets, rigid body being the type.
Okay, so the next function is onEnable, and this is called when this script is turned on. So it'll be called after awake, but before any of the updates happen. So what we're doing in onEnable, I should mention beforehand, the way we're dealing with the tanks dying is we're turning them off. We're setting them to be inactive. And so that when we turn them back on for the next round, onEnable is called. So when they get turned off, onDisable will be called. When they get turned back on, onEnable will be called. And we can use those to set up the various defaults that we need. So for example, we don't want the rigid body to be kinematic when we turn the tank on. If it was kinematic, then we'd have trouble moving it.
So kinematic just means that no forces will be applied. So when you talk about moving physics objects, you're either moving the position to a particular place or moving the rotation to kind of turn them around, or you're adding a force. So you're basically hitting them and moving them around. We're using a function called move position, which we'll use to drive the tank around. But basically, if you don't want any forces to be applied to it, so say your tank gets hit by a shell and it's kind of flung around the object, but that's when it actually explodes and dies, as we put it, then you don't want that tank to keep moving when the round resets. So you don't want that residual force being applied to it. So we use is kinematic. Kinematic mode being on just basically means that no forces can affect it. So for example, if you were making a pinball game and you wanted a physics object, which is the hammer that hits the ball, you'd make a kinematic hammer so that when it hit the ball, it didn't bounce off. It just hit and fires out the ball. So kinematic is if you want physics, but you don't want physics forces to affect. So our on enable, on disable is basically taking care of that. So when we switch the tank on, we make sure it stops being kinematic, so you can drive it again. But when it gets disabled, we put that kinematic on to stop all the forces moving it whilst it's invisible. And you'll see that as we go through the day.
So the other things that we want to do in on enable are reset the values for input, so it doesn't start driving straight away. We need to commence driving.
Yeah.
Okay, so after on enable and on disable, we've got start. So in start, as I mentioned before, we're setting up those axis names. So the movement axis vertical plus player number. So for player 1, it's going to be vertical 1. And as we saw in the input inspector, that's going to call the correct axis.
Yeah. So we've got horizontal 1 there, for example, and we've added in a little note there just saying it's a keyboard axis for player 1. So if you were going to make, and as you'll see if you download the multiplayer networked version of Tanks tomorrow, you'll see that we've added in gamepad, axis, and all of those kind of things. So you can just extend that.
Okay, so we're setting up those two axis names, and then the last thing we need to do is store the original pitch of the movement audio so our tank doesn't keep on getting higher and higher pitched.
So one important difference to notice here is that with the rigid body component, what we did is to say, oh, we're just going to use the awake function and get component to store a reference to that component. So why aren't we doing that now? Well, if you remember, the tank has 2 audio sources. So the tank audio source could be either of these. And what tends to happen is it will pick the first one it finds. So we want to be very specific about the one that we're using for movement and guarantee that we know what we're doing. So what we've done with that is to store it as a public audio source. So instead of a clip that we're dragging on, we're actually going to drag the name of that component and drop it onto the script. And we'll do that after we've finished the script. But this is a reference specifically to that. So once we've assigned that, we can then say .pitch to just grab the pitch property of that component. So what you'll see when you look there is you can adjust it here. It's just this little slider. It's just going to grab that original value and store it for us so that we can randomize it as people drive around. And that's our start function.
Right. So first thing we want to do in update is store the values of input, because update is where input is calculated. So that's the best place to grab it.
So update is running every frame. So if the game's running 30 frames or 60 frames, it's running that many times per second. And we use it to store input, and then we use fixed update, which looks very similar as a couple of functions down, to actually apply that movement. So you'll see that in a moment. So as James said, we're going to use that to get the input.
So what we're going to do here is m_movement input value.
So what I want you to just notice, and we'll do this a bit at a time, as I've started typing this, I've got this autocomplete. Now, autocomplete isn't entirely reliable. Sometimes it doesn't quite know what you're doing and gets confused. So sometimes it won't come up. You may have to look at exactly what I'm doing and just double check your code. But what I want to point out is that when this autocomplete does come up, I can use my arrow keys to just go between these different things. And I can select the one I want, hit return to finish it off. So movement input value equals
input.getAxis. And then getAxis takes a parameter, and that parameter is the movement axis name. So you remember we set up that string, passing in that string to get the axis. And then very similarly, for the turn axis, we're doing m_turn input value equals input.getAxis m_turn axis name. So all that's doing is it's finding the value of two axes and storing their values. So we're not going to use them too much in update, but we are going to use them quite a lot in fixed update where we actually move the tank. Okay, so the last thing that we want to do in update is put a call to the engine audio function. You do that by typing engine audio, open parentheses, close parentheses, and then semicolon for the end of the line. We're going to have all of the engine sounds managed by its own function, so we're just going to put a call to that function in update so that every frame is making sure it's playing the right audio. And the next thing we're going to do is actually make that engine audio function. So you'll notice we've got an empty stub of a function there, and we're going to complete it.
So I'm going to leave the comment at the top. I'm just going to put my cursor at the end there and hit return a few times to move down.
Okay, so the basis of this function is if the tank is moving, then we want to play the engine driving sound effect. If the tank is stationary, then we want to play the engine idling sound effect. But we only actually need to change those or vary the pitch if the wrong one is being played. So if we're moving and the engine idling sound effect is being played, then we need to do something about it. If we're stationary and the engine driving sound effect is being played, then we need to do something about it. Mm-hmm. So the first thing we're going to do is create an if statement and an else statement to work out whether we're moving or whether we're not moving. So in the if statement, type if open parentheses, mathf.abs, and I'll explain this line after we've typed it. Mathf.abs, open parentheses, m underscore movement input value, close parentheses, less than, so a little arrow sign.
It's a left chevron. I don't know if that makes sense, or a left angle bracket, depending on what you want to call it.
And then 0.1f, and, which is a double ampersand sign, mathf.abs, open parentheses, m underscore turn input value, close parentheses, is less than 0.1f. And then close parentheses. And after that, we can put on a new line, open brackets, and close brackets. So we've got the structure for us there.
Real quick note, with these curly braces or brackets, as you guys call them, I tend to put them on a new line. What MonoDevelop likes to do is force you to not put them on a new line. It will tend to put it next to the same line. You can just do undo, which will just put them back where you intend them to be. It's a little tip for MonoDevelop. So let's talk about this actual line of code and what it does.
Okay, so you notice we've got two parts. We've got one part that's about the movement input value, and then another part that's about the turn input value.
So part one here is comparing less than, and then this just means this condition here, 1 and double ampersand, that's what that means. Also, this condition must be true for us to carry out the instructions in this if statement.
Okay, so that first part is mathf.abs of the movement input value, if that is less than 0.1f. So the absolute value of a float is just the positive version of it. So if it's 0.1, then it'll be 0.1. If it's minus 0.1, then it'll also be 0.1.
So the reason we do that is that the input value is going to be a value from -1 to +1, with obviously 0 being a kind of idling. So for example, if our movement input value would be holding the up or down keys on the keyboard, right? When I'm holding back, it's going to be -1. When I'm holding up, it's going to be +1. So we need to convert this to be a positive number because we just want to compare it with 0.1. We want to know whether if you're driving backwards or driving forwards, you're driving slightly. And when it gets to 0.1, then you know that you're driving somewhat. And same for turning.
So as we were saying there, we're saying if you've got a little bit of input at least in the vertical plane or in the horizontal axis, then you are moving. So within this if statement, we know that the tank is moving. Also, we all want to deal with the case where the tank isn't moving. So what we're going to do before we go into that if statement is we're going to put the else statement. So outside of the if statement, type else, and then some open and close brackets.
So here's that example. If I press return now, put in my brackets, it's going to move them for me. I can just hit undo and move them where I want. I tend to lay out code like this, but if you want to do it slightly differently, that's totally fine.
Okay, so now we've got some open close brackets for if the tank is moving, and we've got some open close brackets for if the tank isn't moving.
Yeah, so the else is dealing with if we're driving around, the if is dealing with if we're idling.
Okay, so within the if statement, we're going to need another if statement. So remember, we've just said the tank is idling, so it's not moving anywhere. So we only want to do anything if the clip that we're currently playing is driving. So that's what we're going to check for next.
Also, when James says within, we just mean after the opening brackets and before the closing one. So this is why I kind of lay out code that way so you can see that a bit more easily. So on this line, we're going to put in a new if statement.
So this if statement is going to check that audio source that we gave it and check its clip. So we're going to say if, open parentheses, m underscore movement audio dot clip double equals, and then m underscore engine driving, close parentheses, and then some open brackets. Okay, so what this line is doing is saying, you know that audio source that's on the tank? Check what clip it's playing. If that clip is equal to engine driving, and that's the double equal sign, it's checking whether something is the same as something else. If it's engine driving, then we know we're playing the wrong one. So we need to do something about that. So what we're going to do is say m underscore movement audio dot clip, and then set that to engine idling. Okay, but that's not enough. We also want to vary the pitch so that we don't have that same sound horribleness. So m underscore movement audio dot pitch, and that is equal to random dot range. We're going to write this out first, and then I'll explain it afterwards. So that's random dot range, open parentheses, and then it's got two parameters. And the first parameter is m underscore original pitch minus m underscore pitch range. And then after a comma, the second parameter is m underscore original pitch plus m underscore pitch range.
Just going to try and fit that on screen for you all.
So don't forget the semicolon at the end of the line.
Thanks, James.
Okay, so what we've done here, we've switched which clip the audio source is playing, and then we've addressed the pitch and said, set it to a random value in a range that is between the original pitch minus that range that we gave it, and the original pitch plus a range that we gave it. So the original pitch, I think I remember, is being 1.
Just 1, yeah.
So minus a pitch range is going to be 0.8, plus the pitch range is going to be 1.2. So we're saying set the pitch to a random value between 0.8 and 1.2.
Yeah. So you might ask, oh, why don't we just write 0.8 and 1.2? Well, we might want to change what the original pitch is. We want to redesign the game a little bit. Then, you know, this will still work, whatever we do with it. So we try to avoid what we call magic numbers. So just plugging in an absolute value that we'd have to go back into the code to change.
The last thing that we're going to do there is once we've changed the clip that an audio source is playing, we need to tell it to play that clip again because it's going to stop. So movement audio dot play, open close parentheses.
Yeah, this is just a simple note. Whenever you change clips on an audio source through code, you do just need to call the play function. So again, a function is usually denoted by a capital letter at the start. Capital letter P for play there.
So that is all we need to do for when the tank is idling. When the tank is driving, we need to do very, very similar things, but switch around the clips. So all we're going to do is copy that inner if statement and paste it within the else statement. So that's within the brackets of the else statement.
So I'm just going to show you this slowly. So I'm selecting all of the if statements. So from the opening if to the closing bracket that's taking care of that. I'm going to copy, so Control C or Command C on Mac. And I put my cursor within the brackets of else, paste in there. Then the things that need changing are my engine driving and engine idling. So as we said before, the first one handles if you're idling. We check if it's currently driving, we set it. So we check is the clip currently driving? If so, set it to idling. And then this is the opposite of that. If it's currently idling, we need to swap it around. So all you need to do is just retype that and retype that one. So for me, this is lines 76 and 78. It might be slightly different depending on how you put your brackets. But your second if statement there should say if m_movement_audio.clip double equals m engine idling. So if we're playing the idling clip, don't do that, play the engine driving. And then the other things are just the same thing. We always want to randomize the pitch, and we always want to make sure we play the clip. So we've got the same two lines that we did before. As we're going through the code, just keep Control-S or Command-S to update the script to make sure you save it again in case you lose any work.
You'll notice that we're saying that the absolute value of movement input is less than 0.1 f. So what that f is doing is saying treat this number as a floating point value. Because there's multiple different types of numbers in programming, and this is a way of telling the compiler which type of number we're using. So we always want to use floats, so put an f at the end.
Okay, so I'm going to move on a little bit, but I'm just going to keep that code up at the top of the screen and type down here, so hopefully anyone's still typing, they can still see it. I'm just going to move into the fixed update function now. In fixed update, what does that do? Well, it's a similar name to update, but instead of running every rendered frame, so every visual frame, what it's doing is running every physics step. So the physics engine will run what we call steps. So a bunch of kind of instances where it updates itself every second. And then the updates that we want to do with that are things to do with physics. So we want to move the tank and we want to rotate the tank. So we just put a call to the functions that handle that into the fixed update function. And that means that it's going to move in step with the physics engine. So all I'm going to do is put in move and turn into those. And we're going to go ahead and write those in a moment.
All that we need to do in physics is move and turn the tank, and we've got our own functions to deal with that, so all we need to do is put calls to those functions.
So you'll see that we've added these, what we call stub lines. I'm just going to move those up the screen so you can see them more easily. And they are move and turn.
So in the move function, what we need to do is do two things. We need to calculate how far the tank is going to move, and we need to move it. So first of all, we need to calculate the vector that the tank is going to move along. So for that, we create a vector3 variable.
What is a vector, James?
A vector, in our case, is three values, x, y, and z. So for a change in x, a change in y, and a change in z, in our case. So we're going to create a vector3 called movement, and we're going to set it equal to transform.forward. So that's a vector representing the forward direction of the tank. And that's going to be multiplied by m_movement input value. And that's going to be multiplied by m_speed and time.delta time. Okay, so what is that doing? It's creating a vector in the tank's forward direction that's scaled by the amount of input it's receiving. So if it's receiving an input value of 1, then it wants to go forward, so it's going to be transform.forward still. If it's receiving an input value of -1, then it's going to go backwards along its forward vector. We're next going to multiply that by speed. So instead of moving 1 per frame, it's going to move the amount of speed per frame.
Which was 12.
So per frame, it's going to move 12 units. But we don't want it to move that far per frame. So we're going to do multiply by time.delta time to instead make it proportional to a second. Rather than per frame, it's going to move 12 units every second.
So it's basically just a way of kind of smoothing that out per frame. If you see, you'll see a lot of times time.delta time in Unity projects. It's just a way to guarantee that you're not moving something, many times every physics step. You're instead doing it per second. So don't worry about that too much. So what are we going to do with that vector?
Okay, so now we've worked out what our movement's going to be. We want to actually apply that to the rigid body. So the way we do that is we say m_rigid body dot move position, and then open parentheses m_rigid body dot position plus movement. So what move position does is it moves a rigid body to the absolute position that you give it. So if we say moved it to just movement, if we missed out that rigid body dot position in there, then it would always move around just around the center of the world and never move anywhere at all. So if we add the current position to that movement, then it's going to move relative to itself and it's going to start moving around the world. Okay, so let's move on to the turn function. So the turn function is very slightly more complicated, but we'll draw some comparisons and it'll be quite easy. Okay, so the first thing we want to do is create the amount that we're going to turn. And instead of it being a vector, we want to float because we need to know how many degrees we're going to turn. So in order to create this float, we're going to give it the input value. So m_turn input value. We're going to again multiply it by the speed, but in this case it's the turn speed, so m_turn speed. And again we're going to multiply it by time.delta time. So what this is doing is creating a number of degrees that we want to move per frame. But Unity doesn't deal with rotations in floats. It doesn't actually deal with them in vector 3s like it shows on the inspector. It actually deals with them in something called a quaternion.
So a quaternion is just a way of storing a rotation, and that's kind of all that you need to know is that Unity's using this data type to store it internally. But we can feed in a vector 3 into a particular function to turn it into a quaternion, and that's exactly what we're going to do right now. So I'm going to say quaternion.Euler, and then I'm going to give it an x, y, and a z value. So we know that when we're turning the tank, we don't want to turn it around x because it would just be flipping over, and it could be cool, but we're not going to do that. So 0f for x. Then we want to feed in a value for y, and we've just calculated that, as James said, that's turn. That's the amount, so we don't need to put in a number, we'll put in our variable name. And then finally, we don't want to move it around z, we don't want it to spin forward. That would also be pretty cool, but we're not going to do that.
No barrel rolls.
This is not Rocket League. So instead, we're just going to put in 0f there. Again, we're using the f's just to tell this that they're float values. So a vector 3 is made up of 3 float values, and that's what this quaternion Euler is expecting.
A quick note, we've created a variable called turn, which is a lowercase t here, and the function has an uppercase t, so make sure that when you've called it and created it, you've created it with a lowercase t, because otherwise the compiler is going to get confused between the variable and the function. Okay, so now we've created that quaternion that we can use to turn the tank. So we're going to do something very similar to the move function. We're going to say m_rigid body dot move rotation. So instead of move position, it's move rotation. And again, we need it to be relative to its current rotation. So m_rigid body dot rotation. But you can't add two quaternions together. It doesn't actually make any sense. So what you need to do is multiply. So we have the rigid body's rotation, and then we multiply by the turn rotation that we created. And that's all there is to it.
Yeah.
When you are done, save your script, and then we can return to the editor.
So switch back to Unity once you've done that, and what you'll see that either you've copied it out exactly correctly and understood everything and everything's cool, or you might have some errors which will show at the bottom in the console window. So what I'm going to do is just save my script and switch back to the editor and see if I've made any errors. If you've done it correctly, what you'll see is if you just save briefly in Unity and then press play at the top,
not a lot's going to happen.
Not a lot's going to happen, and you'll get an error at the bottom. So you'll see this unassigned reference exception. So what does that mean? So basically, whenever we create public variables in a script, the idea is that we will then assign something to them in the editor. And we'll do that in a moment. I'm going to deliberately add an error into my script. So I'm going to put in another value in here for no reason and save my script. When I am in Unity, what Unity is going to do, if I go to Window Console, Command-Shift-C or Control-Shift-C, Window Console, I will have a list of all the errors that I've got right now. So the thing that I just put in, it will show me which line it's on, and it will tell me a rough approximation of what I've done wrong. So it says, oh, hey, this doesn't make sense that it takes 4 arguments. Why have you put 4 different things in? Because what I've done there is I've put in 4 instead of the 3 values that it was expecting. So if I save that and return back to Unity, it will recompile, it will think, and then I'll get back to the actual real problems that I've got. So I'm just going to talk briefly about what we've just done to kind of refresh everyone's memory. That would be cool. So in this script, we handled getting the input for the tank. So remember, we stored references to the inputs. We got the values, and we were in charge of reading those values and applying them to the actual movement functions. We set up the audio so that we know that when we're driving, it's going to play the right clip. When we're idling, it's going to play the right clip. And like I said, we're setting up forward, backward movement, and obviously turning as well. Now, once we did that, we returned to Unity and we fixed all of our errors thanks to the wonderful, helpful team. But we can't play the game just yet. Now, that's because we need to populate the script and its public variables. So I'm just going to show you that script as a component once more. So tank movement should look like this. And because we created some of those public variables with values, so numbers, for example, so the player number, the speed, the turn speed, they're already filled in. So it just reads them in. And if I change them here, then they're not going to change in the script. What's in the inspector always overrides what's in the script. But we do need to fill in these three fields: movement audio and engine idling and driving. So as I said earlier, the first one there is an audio source. It's not a clip. We're not going to be able to just select something. We're instead going to just drag and drop the audio source that we want to use. So the movement audio is being played back by the first audio source. So what I want you to do, and just watch this first, is just grab the name of the audio source by clicking here, and then drag and drop it. You can see it says tank audio source where I'm holding my mouse button down. Drop it onto movement audio. That's going to assign anything that's being played via that variable to play out of that audio source component. The other two should be straightforward. It's using the circle select button to the right of the field to pop open the selection window, this thing. And the first one is engine idling, is engine idle clip, and then clicking the circle select to the right of engine driving and choosing the like named clip there. Once you've done those, you can then save your scene, test play, and you should no longer get those errors, because the errors that we were getting before were what's called an unassigned reference. So it basically was saying, hey, this movement audio thing, this audio source hasn't been assigned. You need to probably do that in the inspector. So we've done that. So I can clear my console. And if I press play, I can drive around. So what you'll notice is that the pitch is varying, but only slightly. So the main idea with this is because we're using a multiplayer game on one screen, we're using audio that we don't want to phase. It's what we call 2D audio. It's not based on distance. It's going to play back at the same volume throughout the game, depending on where the tanks move. Because you don't have one avatar for the person who's playing the game. You've got two people looking at the same screen, playing the same game. So to have them playing back the same sound will create what's called phasing, and it would just sound horrible. So we vary both pitches at the same time. That could overlap. There could be some random situations where they're playing the same, but each time they change where they're driving or rotating, it will vary the pitch again. So you're hopefully avoiding a lot of phasing with this approach. So that is our tank movement script. We've now assigned our variables. So I'm just going to jump back, quick recap of those. So we assigned our audio source, we dropped it onto the movement audio variable, and for engine idling, we used circle select to choose engine idle audio clip. And then for driving, we did the same. Now, the next step, as you can see on this slide, is to update the prefab. So we need to update our prefab, and I'm going to show you where that is. So when the tank's selected, I'm just going to collapse that so we've only got the tank selected. You'll see up at the top, prefab, select, revert, and apply. We just want to hit apply because right now, before I do that, I'm just going to show you that what I've got here is different to my prefab. Currently, my prefab's just got the audio sources, the collider, and the rigid body. But my version of that prefab in the hierarchy or our current scene is different. It's got the tank movement script and it's got the different variables of that script assigned. What you'll also notice is that these are in bold. It's hard to tell unless you look at something that that isn't in bold. Notice that the text here, script, player number, etc., is more emboldened than this. That's just alerting me to the fact that these are different to the prefab. So as soon as I update the prefab with these settings by hitting apply, you watch and you'll see that these aren't bold anymore. So I hit apply, it goes back to normal, and that tells me that the version in the scene is exactly the same as the prefab. So go to the prefab settings at the top, hit apply. You can hit it as many times as you like just to make sure, and then you can save your scene. So we've updated the prefab at the top of the inspector. So any future tanks that we drag out of the inspector will be the same as our updated version. And then we're just going to save our scene, file save. Okay, so hopefully everyone has been able to play test their game. Just going to turn that down. Of course, what you'll notice is that we don't have the ability to move the camera around just yet. So it's kind of a boring game where the tank just disappears and, you know, it's off to find its destiny. So that's that done. We've saved our scene, and that's the end of phase 2.